Hi everyone, today we are going to find trigonometric ratios if a point on the terminal side is given. We have a point 3, -4 on the terminal side of the angle theta, and we have to find the exact values of each of the 6 trigonometric functions of theta. So the first step would be to plot the point on the graph, and I'm going to draw my grid here, a rough sketch. I'm going to mark 3. 3 is positive, so it will be on the positive side of the x-axis. And then we have -4. So -4 will be right here, 1, 2, 3, and somewhere here will be 4. So my point is going to be somewhere here. And I'm going to connect this point with the origin. And after that, I'm going to drop a perpendicular from this point to the x-axis. So that's my right triangle. I'm going to write down here 3, -4. So, and we have an angle here that is getting made, and this angle is going to be theta. Now, we are going to look in the direction opposite to theta, and that's going to be our opposite side. I'm just writing an O for opposite. The leftover leg is called the adjacent. So that's my adjacent over there. And then the angle opposite to the right angle, sorry, the side opposite to the right angle is called the hypotenuse. So if I go and look at this now, I'm going to see that this side, the opposite side is it's going to be our -4, and our adjacent is going to be 3. That's equal to 3. And hypotenuse you'll have to find. So what I'm going to do here is I'm going to go and let me erase this one here and then write. So this was A equals 3. I'm going to draw this triangle all over again so that it's more clear. So here we go. I'm going to go and draw this triangle, clearer triangle. This is my triangle over here, and this is the right angle. So this is going to be -4, and that was 3. And again, this is the opposite, O for the opposite, and this one is the adjacent. Adjacent is going to be a 3, and hypotenuse you have to find. So I'm going to write a question mark here. Now we're going to go and use the Pythagorean theorem and find the value of the hypotenuse. So the Pythagorean theorem is going to be a squared plus b squared equals c squared. So that's a squared plus b squared equals c squared. So our a is 3, and then we can just take any of the legs as a and b. Those are our two legs, the perpendiculars. So we are going to take 3 squared plus negative 4 squared, and we are going to find out what's it going to be. So that's 3 squared plus negative 4 squared equals c squared. And 3 squared is 9. Negative 4 squared will be 16. Pardon me for this one. Let's write it here. So it's going to be 9 plus 16 equals c squared. And 9 plus 16 is 25 equals c squared. You can take the square root of both the sides. And if we take the square root of both the sides, it's going to be, so I'm going to take the square root of 25 equals square root of c squared. The square root and the square gets cancelled here. And the square root of 25 is 5. So your c is going to be 5. So going back to our triangle, this side, the hypotenuse is going to be 5. I'm going to write it 5 here. And I'll just go and write this once again. I'll draw the triangle once again. So we have 3, negative 4, and 5. So that was 3, that was negative 4, and the hypotenuse was 5. So again, I'm going to write, so that was theta, right? So that's an angle theta. Opposite to the angle theta is our O, the opposite. This is our hypotenuse, and this is our adjacent. So now coming to the trigonometric ratios, I'm going to show you here. So how to do it. So we have a magic word called so, and so basically lets you remember the formula. So I'm going to write sine theta. So that's sine theta equals O is the opposite, O over H, which is the hypotenuse. So, and you can clearly see from your picture, O is negative 4 over, and H is 5. Therefore, sine theta is going to be negative 4 over 5, and we're going to put it in the box. So that's our sine theta. And let's do cos theta. Cos theta, and the magic word for cos theta is ka. That's adjacent. over hypotenuse, and your adjacent is, if you see here, adjacent is 3, hypotenuse is 5. So we are going to write 3 over 5. So 3 over 5, and that's your cos theta. And again, we are going to box it. And then let's go and find the tan theta. So tan theta. So our magic word is TOA, and tan theta equals opposite over adjacent. And if we go and look at our triangle, opposite is -4 and adjacent is 3, so -4 over 3. So -4 over 3. Again, we are going to box it, and that's our tan theta. Now coming to the rest of the trigonometric functions. So basically, the rest of the trigonometric functions are the reciprocals of sine theta, cos theta, and tan theta. So what we are going to do is, we are going to look at sine theta here. And so the reciprocal of sine theta is cosecant theta. So cosecant theta is equal to the reciprocal of sine theta. That's going to be hypotenuse over opposite. That's equal to 5 over -4. And if you notice here, positive over negative is negative. Therefore, the negative sign floats up. So it's going to be -5 over 4. And again, we're going to put it in a box. And that's our cosecant theta. Next, we are going to find the reciprocal of cos theta, which is secant theta. So secant theta is equal to hypotenuse over adjacent, which is equal to the reciprocal of cos theta is going to be 5 over 3. And again, you can put it in a box. And that's our secant theta. And finally, we are going to go and find the reciprocal of tan theta or tangent theta. So the reciprocal of tangent theta or tan theta is cot theta or cotangent theta. And that's going to be adjacent over opposite, and flip -4 over 3, that's going to be 3 over -4. 3 over -4, and positive over negative sign is going to give you a negative sign in the answer. So -3 over 4, and that's our cotangent theta or cot theta. And again, we are going to put it in a box. And we're done with this question. We found the 6 trigonometric ratios when the point on the terminal side of the angle was given to us. So with that, we end this video. Take care. See you next time.